Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss measurement of electrode potential. But before measurement of electrode potential, I want to discuss some basic concept. Last class I have discussed many things. Now I will, you can say, tell something more for basic knowledge. After that, I will come to measurement of electrode potential. Last class, I have discussed how to represent a cell. Then, suppose as for example, you have two rod, two metallic strip. Then anode you have to write, first anode you have to write. Okay, after that you have to give two vertical line, two parallel vertical line. And then you have to write cathode. Anode first to write, after that two vertical lines, that is for separation for anode and cathode. And actually this double vertical line, parallel vertical line, that tells about the salt bridge also. Then first you have to write anode, and then you have to write two parallel line, vertical parallel line, and then cathode. This is actually representation of a cell. But here also, what is the anode side and cathode side down? Anode you have written, cathode you have written. Two vertical line you have written, parallel vertical line. Then near the anode, you should write concentration of electrolyte. And that side also, cathode side also, near the cathode, you should write concentration of electrolyte. Okay, because metal will be dipped in the electrolyte. As for example, Zn in ZnSO4. Then ZnSO4 is electrolyte. Then what is its concentration? That concentration you have to write. Suppose concentration is C1, and then you write C1. Okay, and that side concentration is C2. Then write C2 concentration. Value of C1 and C2 you have to write. Suppose ZnSO4 has concentration 0.1 m, and cathode side copper sulfate solution, copper in copper sulfate. Copper sulfate, suppose its concentration is 0.2 m. Then you write 0.2 m. Correct? Then this is the correct way to write the to represent the cell. Then how to write anode, how to write cathode also I have discussed. Then for anode side oxidation, and anode is given negative sign, cathode is given positive sign, don't forget. Then anode side oxidation, cathode side reduction. Then anode, how will you represent? Anode, how will you write? Then here metal, and again oblique sign, and metal ion. Metal will convert to metal ion. That's why you are writing metal and one vertical line and metal ion. M, then one vertical line, and then M, N plus, capital M. Capital M means metal. Metal is converting to metal ion, means M, N plus. M power N plus. N means a small n, valency N. You don't know how many electron it will lose. That's why N term you are using. But that is true. After losing the electron, it will give cation. That's why N plus you are writing. Correct? Then anode, when you are writing, then metal you write oblique sign, means one vertical line, and then metal ion. Metal is converting to metal. As for example, Zn is converting into Zn plus plus. Then Zn oblique line means one line, vertical line, again you write Zn plus plus. That is the anode. Now at cathode what will happen? There reduction will take place. It is this side oxidation. On anode always oxidation takes place in galvanic cell. Okay. And cathode always reduction will take place, means it will take electron, metal ion will take electron and it will convert to metal solid. S you can write metal solid. Then capital M, N plus means metal ion you are talking about, like a copper, Cu2 plus. Then it will convert to, after taking electron, it will convert to 2 electron it will take and it will convert to copper solid metal. Then here you can write cathode side Cu2 plus, or in general M N plus, capital M power N plus oblique means here one vertical line and then you write capital M means metal ion is converting into metal reduction. That side oxidation, this side reduction, reverse. Then this is the way how to write, how to represent anode. Then example you can take, best example that this Daniel cell example you can take, means Zn is a anode, copper is cathode. Then you can write one example I am telling you, Zn oblique Zn plus plus, double line, double vertical line, double parallel, both lines should be parallel, vertical, and then you write this thing Cu plus plus oblique Cu, correct? And concentration down you write whatever concentration is there. Suppose it is 0.1 m, write 0.1 m. The cathode side suppose it is 0.5 m, write 0.5 m, whatever be. Okay. This is the important things, very important things I told you. And how will you calculate the E cell? How will you calculate the E cell? Then E cell is equal to ER minus EL, means electrode potential of right hand electrode, right hand side electrode potential, right hand electrode potential, and left hand electrode potential, E, denoted by E, means capital E, down you can write RH, right hand electrode, RHE, RHE minus E, left hand electrode, LHE, correct? That difference is called potential difference, that is called cell potential, E cell, that is called capital E and CE double L. Then E cell is equal to ER, in shortcut ER minus EL. This is the formula. You can solve very easily numericals. Generally nobody will touch the electrochemistry numericals, but if you are understanding, or if you will understand, quickly you will solve the numericals. Now question they will give that potential they will give for right hand also, potential they will write, and left hand also value they will give, reduction potential they will give, both potential in term of reduction potential only they will give, correct? Oxidation potential also they will give in terms of reduction potential, and reduction potential automatically it will be reduction potential. Then if potentially they will give both potential, then right hand potential will be known, left hand potential will be known. Then you can write, you can calculate very easily, only minus you have to do. Suppose right hand side value is 0.34 volt. Right hand potential, suppose copper, then copper electrode potential is actually it happens a standard electrode potential, that is actually reduction potential, right hand, then their value is 0.34 volt, minus zinc potential, zinc electrode potential, then its value is minus 0.76 volt. This is a value of reduction potential of Zn, reduction potential. Actually, it was a plus oxidation potential. Oxidation potential sign will be different. Then here, plus sign they have converted to negative. Now, both became in reduction term. Same currency, reduction term. Then now, this for zinc, it is a minus 0.76 volt. It will be given. Then now, easily you can calculate 0.34 for copper means Er minus El. Then that value is 0.34 minus, in bracket you write minus 0.6 minus 0.76 minus 0.76 volt. Both are in volt. Hence quickly I can solve it. Minus will become plus, then 0.34 plus 0.34 plus 0.76 minus become plus, then 1.10 volt. See, quickly solve the numericals. Then this type of numericals they will give you. That is very easy to calculate. This is the very, very important things I have discussed. Now, one more things I want to tell you. All are coming under the basic. Here, this galvanic cell I told you, studied in details, I discussed this galvanic cell. Then now here that electrons flow from the anode to cathode. Electron flows from anode to cathode, and direction of current will be opposite of this. Correct? Means from cathode to anode. Cathode to anode. Correct? Then now I will discuss about the direction only. If you will, you can say these things, if anode potential is more than cathode potential, that potential actually depends upon the equilibrium position, because anode is dissolved in solvent. Solvent means a solution, you can tell. That is a suitable metal and solvent is there. Metal is dissolved into the metal and solvent. Zn in ZnSO4. Then already told you that there in the solution equilibrium will be established. Then due to that equilibrium, because Zn is converting to Zn ion plus 2 electron, that equilibrium will be there. Zn sign of equilibrium, Zn plus 2 electron. Then this creates potential. Then here actually here anode has more tendency to lose the electron, more tendency. That's why it will develop more potential in comparison to the cathode. Cathode will develop less potential. Correct? Then more potential anode side, less potential cathode side. Then just like water flows from high to low, high surface to low surface, water flows. Then current also, or electron also, you can say flows like that. Actually, this electrons jumps, not the flow. Current you can take flow. Current flows. Just like water flows from high level to low level, same way current flows from high to low. Then here potential also, one side is a high, other side is a low. Then high potential to current will flow from high potential to low potential. Means electron is going from high to low, and it will go until both side potential will become equal. If potential at anode and potential at electrode is equal, then just like in the same level water will not flow. At the same level water will not flow, because both are same height. Same height, then it will not flow. But now third case you can see, when right side is high, means cathode side, suppose is high, then it will flow from that side to anode side. But wherever it is high, that is anode. That is a thing, sir. Means direction can be changed if potential will be more. Okay, means suppose A and B, then A has more potential than B, then this current was flowing from A to B. Voltage was high for A and less for B, then A to B. But now suppose by artificial means, if you have increased the potential of B, then now direction of flow will change. Direction of flow of current will change. So now from B it will go to A. Then direction can be changed. Okay. Then generally it happens when actually I told you reaction is of two types, spontaneous and non-spontaneous. Spontaneous means if you will mix both A and B, you are mixing, then reaction will take place. You have to not heat, you have to not do anything. Just you have mixed, reaction will start. But sometimes A and B will not react after mixing. Then you have to do some things. You have to heat it. You have to put catalyst, something you have to do. Then reaction will take place. That type of reaction which is not taken by your own. You have to give some condition, extra things you are applying like heat, catalyst, then it will react. Then that type of reaction which is not reacting itself by your own, then that is called non-spontaneous. Then like that way I was telling you, if from the outside if you will apply these things, voltage from outside, external source, then which side you want to give more, that side you apply. You can connect, correct? Then there where you are connecting, that will be actually, where you are connecting, that will be actually in distance cathode. Okay, where you are, that is a different things I will discuss at the end. But here from the outside if you supply volt, then that side it will be more volt, other side it will be less. Then direction can be changed. Okay, don't confuse. Okay, now we have understood. These are the important things, how to change the direction of flow of current. Wherever volt will be more, from that side it will, another side it will flow, from that side to the another side. Now another important point I am telling you, that is anode and cathode. I have told you to whom, which rod you will make anode, which rod you will make cathode. Last class I have discussed. Okay, anode will be negative charge, cathode will be positive charge in galvanic cell. Okay, then here how will you determine first how will you make anode? Then I told you which has negative means less potential, that will be anode. Which has more potential means positive, that is cathode. Simple way. Negative, if one can say electrode is negative value, negative volt, and other has a positive volt. The negative, which has negative, that will become anode, that will behave as a anode. Which has positive value, that will behave as a cathode. This is the criteria. If suppose both are negative, then what will happen? Many metal may be there, both may be negative value. Then there again principle is same. More negative will be anode, and less negative will be cathode. Understood? Like that way, if both are positive, then less positive will be anode, more positive will be cathode. Don't forget. If both are positive, as for example 1.1 volt and the other is 2 volt, 2.0 volt, then 1.1 volt, metal which have 1.1 volt, that will be treated as anode, and more volt, that will be treated as cathode. If both are negative, as for example minus 2.0 and other is minus 1.0, then minus is more negative, then minus 2 electrode which have minus 2, that will behave as anode, and other minus 1, that will be cathode. Correct? I am telling you this concept, if you are understanding, then very easily you will solve the numericals. As students gets confused, always they will fear from the numericals of electrochemistry, and those who will solve the, already I told you, physical chemistry numericals, they will be the topper, sure shot. Because those who are in a position to solve the numericals of physical chemistry, it means they will be the topper, because in organic is comparatively less. There you can remember, or they can write something, but here without concept you can't touch, you can't give any answer. Physical chemistry, that is the toughest, actually toughest among all chemistry. Okay, then here this I think now we have understood. Then if both will have same value, then what will happen? Then there will be no conduction, no, you can say, passage of current. If both electrodes have same volt, same potential, then that you can't use, it is useless. Okay, your purpose will be not solved. Then if negative and positive, that you know, that is very easy. One is negative value, other is positive value, then very clearly that negative will be anode, positive will be cathode. This I told you, a very important things regarding numericals, how to solve. Now these things, another important things I am telling you, that how will you can say measure the these things, potential, measurement of electrode potential. Then here very important things again I am telling you, that always you have to, if you are measuring anything, then one standard is required. One standard is required. In comparison to that, only you can compare with others, whether it is more or less. Then here for everything one standard is required to measure. Actually in real life we are telling that someone weight is 80 kg, other weight is 40 kg, 60 kg, something value. Then how you are telling kg, and how you are telling length? Suppose you are measuring 1 meter, 2 meter, 3 meter, then how will you understand what is the meaning of 1 meter, what is the meaning of 1 kg? Correct? You are telling 1 hour, 1 minute, 1 second, what is the meaning of 1 second? Correct? Then time, distance, mass, MKS system you are knowing, MKS system, mass, M means mass, K means mass, kg, S means second, MKS, just like that. SI system, international system. Okay, CGS system also is there, CGS, centimeter, gram, second. These three things you are telling, centimeter, length in centimeter, mass is in gram, time is the second. Then what is the standard of all these things? Now actually six standards are there. In details if you go, already I have discussed. But here now I don't want to go again in details, but here I am telling you how will you consider 1 meter, 1 kg, 1 second. Then for that, just simply they have considered that they have kept in a museum, they have kept in there's something, a stick like that they have kept made up of some metal, and that length they have considered as a 1 meter, simply without any consideration. Okay, and that is the 1 meter. Like that way they put some mass of some metal, some things they consider as a this amount is called 1 kg, simply arbitrary, that is called arbitrary, no logic, simply. Second also, so for the period they have simply they consider second, that is a standard. And so what you are knowing, we are telling this kilo, that minute, that kilometer and second, but that will vary. You have that is considered standard, you have considered is not exact. What is that value? Simply you have considered that this will be 1 meter, this will be 1 kg, this will be 1 second, and you are only on that basis all things are going on in today's world. Actually we don't know. We can consider big also. Big rod also we can consider as 1 meter. Bigger amount also we can consider as 1 kg. Bigger time also we can consider as 1 second. But this is only whatever has been considered that we are following. That is called a standard. Then here now come to the point that here in just to measure the volt, hydrogen gas, hydrogen electrode, a standard hydrogen electrode, SHE, that is considered as a standard. They have considered its value is 0 volt, arbitrarily, without any consideration that hydrogen gas, standard hydrogen gas electrode, this is electrode, hydrogen gas electrode, it is called hydrogen gas electrode. Its value has been considered as a 0, ZERO, simply, no logic, you have to not argue, arbitrarily, that is called arbitrarily. Then now actually this hydrogen gas, standard hydrogen gas electrode, standard meaning you are understanding, temperature, pressure, same things. Okay, then pressure 1 atmospheric pressure, but here you will use that I will tell you what is the standard hydrogen electrode. Only here I will tell you, suppose you have taken in a beaker HCl solution, you have taken HCl 1 m, 1 molar solution HCl, it will provide H ion plus chloride ion, correct, HCl. Now in this HCl, suppose one long tube, just like a similar type, it is not burette, means that type of tube you can consider, but both end, one end from the middle, just to conduct the electricity, one wire will be there. Generally silver wire will be there, copper also is possible. Then one end, this both end, one conducting wire will be there, may be made up of silver, okay, silver, and or maybe sometimes copper also, generally silver, okay. Then this will be, one wire will be inside long from top to bottom, and bottom what will happen, that one this will be there, Hg, mercury, or you can say platinum foil will be there, down end, that one platinum foil will be attached, correct. Platinum, you know, that is a conductor of current can pass. then that will be one, this will be there, platinum, this will be there, foil. On that foil, that finely divided platinum coated on platinum. Actually, finely divided powder, you can tell, powdered form like that, that is called finely divided platinum coating will be there on that foil. On the platinum foil, platinum, finely divided platinum, just like a powdered form, coating will be there on the platinum foil. Then from the platinum foil to the upside, that inside the tube wire will be there, and it will go up to, and that upside will be closed. After introducing this wire, it will be closed fully round, correct? Round, fully closed, round type of tube will be there. Okay, just, and down also it will be closed. Means both end it will be closed, only wire is passing. Upside also, downside also. Then down platinum foil, on platinum foil, platinum, you can say, coating will be there. Finely divided platinum coating will be there. And from the upside you can connect it with other when you will use this electrode, hydrogen gas electrode, then you require some can say wire not to connect. For that purpose, some wire will be upside, same wire it will come up. Then in this tube, upside one hole will be there, through that you will pass the pure hydrogen gas, not impure, pure hydrogen gas you will pass. Okay, then this hydrogen gas will pass, and here that pressure should be 1 bar. Hydrogen gas pressure should be 1 bar, means atmospheric pressure. This is the condition, because it is a standard hydrogen electrode you are making. Then hydrogen gas, always hydrogen gas electrode should maintain 1 bar pressure, hydrogen gas, pure hydrogen gas. And after that in a beaker you have taken HCl, its concentration is 1 m. And now temperature, just normal temperature, 25 degree at room temperature, just you are doing all this. Then now here actually this hydrogen gas you are supplying, correct? Then H2 you are supplying, platinum wire is there, PT, platinum wire is there, hydrogen gas is there, and in solution hydrogen ion is there, HCl is there, 1 m. Then now what will happen, that hydrogen gas will come down near, there one hole will be there, a small hole, or you can tell that hydrogen gas will be in contact with the wire. But excess hydrogen gas, to escape the hydrogen gas excess, one hole will be there. Okay, then now hydrogen gas is in contact with HCl. Hydrogen gas will be in contact with HCl, not directly, indirectly. Then what will happen, through platinum is there, platinum wire, just to conduct the electricity from one end, it will send to the other end. From there you can make connection with other. Then here what will happen, this H2 will actually, what will happen, equilibrium they will maintain, H2 and HCl. Here these things, hydrogen gas, that reduction will take place. Means hydrogen ion H plus, after taking 1 electron, it will convert to half H2, H plus 1 electron plus E, that will give half H2, hydrogen gas, correct? then there they will maintain equilibrium. Then process is reduction. Oxidation also is taking place. H2, actually at any equilibrium, both process will go oxidation, reduction. Oxidation, reduction. Okay. Then now it will create potential. But whatever potential it is creating, that is a different thing. Simply it is considered as a zero. Then this, what I discussed, is called a standard hydrogen electrode. Standard hydrogen electrodes, and its value is 0 volt. 0 volt. This is called primary reference electrode. Primary reference electrode. Now this is the starting point. Actually, better you can understand that just like in India, that who will become president, who will become prime minister, that question is there. Now suppose many MPs reach to the parliament, 545. Suppose not, it is there, 545. 545 MP reached there in parliament. Then who will become president? Who will become prime minister or ministers? Then there will be this, first they will elect president. First they will elect president. They will, you can say, select one person, neutral person, who is not taking part of any parties. That is actually characteristic, but nowadays real practice it is not like that. But it should be, quality should be like that. It should not support any party. Okay, but all parties should support him. They will tell no, X, Y, that suppose any person X, he will become president. Then now, when all have supported that person, that he will be the, you can say, he will be the president, all supported, thumb majority, full majority, then now president will be in action. President will be in action. And he will select now all. Prime minister he will select. So many ministers he will select. That's why he is giving oath. All will take oath. And only president will, in presence of president. Okay. Then like that way, now president is the head. All are working for him. But in real practice, it is not like that. But all name, in theoretically, all ministers, prime ministers are just like their servant. Their servant. All will work for him on his name. If you will see the any paper, this government paper and that, then you will find that all work is going in his name, president name. Okay, this is super. It is a head for army also. Okay, all army, 3 armies are there, chief, that he is above, first person, all the things. Now here I want to tell you, just like a standard hydrogen gas electrode, now he is the standard. Now this standard hydrogen electrode, he will decide potential of other electrodes. Many electrodes are there. Then what is their potential? What is their potential? Then this will decide. Whole this standard hydrogen electrode will decide. That's why it is called primary reference electrode. Okay, in respect of the SHE, standard hydrogen electrode, other electrode will have some value. How? Now I am telling you. Actually, for a cell, 2 electrode is required. 2 electrode is required for a cell. Then, if suppose you want to know that Zn, suppose Zn electrode, you want to know the electrode potential. Then this unknown, you don't know what is the potential. Then you join with a standard hydrogen electrode. Correct? Means you have made a cell in that one is hydrogen, standard hydrogen electrode, other is Zn. You have dipped in the you can say suitable solution. Suitable solution you have used. Okay. Now suppose cell is ready. One is electrode, other is cathode. Okay. Then here now this both you have joined. Any one you consider as a this thing, because it is a 0, anode you can consider. Anode you can consider as for this for SHE, anode you can consider 0. Okay, or any you can consider, that is not a problem. But you made a cell, you have made a cell. Then here what will happen, that when it became a cell, then there is already you know, then E cell is equal to ER minus EL. ER minus EL. Then here, if you will these two electrodes, if you will join with one potentiometer will be there. Okay, if you will join with this with a potentiometer, then that will be highly sophisticated. Then that will take direct. They will give the value of delta. This thing cell potential it will tell. This potentiometer directly it will tell cell potential. Difference of two electrodes it will tell potentiometer. Then now E cell you are knowing. Then E cell is equal to ER minus EL. Then what you have kept right side, that you write first ER. Suppose hydrogen gas you have taken right side ER, and you can say first write the left side. Suppose you have taken Zn, correct? Then now this difference up to ER minus EL, you have to write the value. Then now total value you are knowing. Suppose now it is showing in potentiometer it is showing minus 0.76 volt. It is showing, suppose, in potentiometer. Then minus 0.76 is equal to ER minus EL. Then suppose both potential and addition of both it will tell in potentiometer. Then here what will happen, that now minus 0.76, that is the potential. Then that is equal to, now you can say electrode potential of both means electrode potential of SHE or plus electrode. Now ER minus EL, now just to apply other side after knowing this, but now both potential is the difference of both potential, it is telling minus 0.76 volt. Then now ER, both potential you added. Okay, potential of left potential of hydrogen electrode, simple standard hydrogen electrode potential plus copper plus Zn. Both you add potential of hydrogen gas electrode plus potential of Zn electrode. Both is equal to minus 0.6 volt. Then now hydrogen electrode potential you are knowing, it is a 0. Then 0 plus Zn electrode, that is equal to minus 0.76. Correct? 0 plus Zn electrode potential is equal to minus 0.6 volt. It means that this Z1 electrode potential is equal to Z1 electrode potential is equal to minus 0.6 volt, minus 0.6 volt. Then now you are knowing the volt of this unknown electrode. Now you are knowing the volt, unknown. Correct? Unknown maybe, here I give an example of Z, maybe copper also, maybe silver also. Correct? Any electrode may be there. But now you are knowing the electrode potential of unknown electrode. And now this is just like you can say with respect to this, now you can know, you can say potential of other electrode. Now in the place of hydrogen you remove, now its work is over, it is a precedent. Now you have selected Prime Minister. Correct? Then like that way, now you are knowing the Z1. Then now again you want to know the copper. Then now you will apply that formula, ER minus EL, that is the E cell. E cell is equal to ER minus EL. Now formula you can apply. Then here, now you are, again you will join with a potentiometer. Then again it will tell the E cell value. Then now E cell value you are knowing, that is equal to, you can say Z1 value you are knowing. Correct? And then ER minus EL means copper you can take. Suppose right side copper was there, then copper is now you want to calculate minus left side, that was the Z1. Correct? Then now what will happen, because E cell you are knowing, and Z1 you are knowing, then copper you can know. Then now its value will come plus 0.34 volt at standard condition. Here also 0 script you have to write for a standard, E0. E upside you can write a small 0, E0. That is the standard electrode potential. Correct? Then for copper it comes, actually it will come total, it will come 1.1 volt. Okay, but whatever it will come such type of value, that copper will come when this is the minus 0.76, then minus plus. Then now you want to know this value, copper value. Then suppose it is a 1.1, total it is showing 1.1. Then 1.1 minus you can say 0.76, because minus plus it became, then now it's this side left, if you bring left side it become minus 0.76, then 1.1 minus 0.76, that will come 0.34. That is for copper. See, then now you are knowing copper. Then like that way, actually this kylomal electrode I will discuss later on. That is, kylomal means they can say Hg2Cl2, mercurous chloride. Okay, that is called kylomal. Then that electrode is considered as a second reference electrode. That hydrogen was the primary, this is a secondary reference electrode. Silver is also considered as a secondary reference electrode. Okay, both are secondary. Then first, because kylomal electrode, real practice, when you are knowing the standard hydrogen electrode, then kylomal electrode, actually you can know, actually it was done kylomal only, silver only. Then these are the reference electrode, both are reference electrode. Then now if you want to know, you can say others, then in comparison to either kylomal or silver, you can know. because calomel or silver, any one can be used as a reference electrode, and with respect to this, other electrode potential you can know. Okay, other electrode potential you can know. Then by following same way, potentiometer is required here always, because it will tell total. It will tell total. E cell it will tell. Okay. Then now this I have discussed very important things here, and now I am stopping only here. Next class again I will continue. Many things I have to discuss. It will take more time. Today I am stopping only here. Thank you.